Hi class, this is Professor Hinderocker here going over your CAP 2 review regarding the forearm and the wrist. We have 10 questions to go over, so get ready to learn. Our first question is right in front of us. It states the athlete's wrist joint is in blank. So as you can see below, the answer is extension. The reason why the answer is extension is because our hands are fully extending forward as she's coming down into her push-up, okay? If we were flexing, our wrist, this part of our hand, okay, the very top part of our hand would be on the floor where our palm is in the picture. And so she's clearly not flexing. It's not circumduction because that's a circular movement that happens near a ball and socket joint such as the shoulder, and or could even be categorized as a conical movement, which is the type of movement that your eyeball does in a circle. So it can't be circumduction because we're not doing anything in a circular motion. It also can't be abduction because that means that the wrist would be going away from the body, and that means that we would be breaking our sagittal plane where we know that flexion and extension always occurs, so it has to be extension. Our second question states the athlete's elbow joint is in flexion as she eccentrically, meaning elongates, lowers into the bottom of the push-up. This joint action is controlled by the triceps brachii. So the important thing to note here is the most difficult part of the movement. As she's doing her push-up, you need to identify where the concentric contraction is happening and then identify the prime mover. So identify the concentric contraction or the eccentric contraction. The eccentric contraction is happening when the muscle elongates. So the muscle that is fully elongating in the agonist, meaning the prime mover, the strongest muscle in this movement, is the triceps brachii. So if we look at this picture, I know it's of a bicep curl, but just hang with me. This is the triceps brachii and this is the biceps brachii. If we were doing a dumbbell curl, then the prime mover would be our biceps brachii and it would be concentrically contracting as we bring the dumbbell up to our chest and eccentrically contracting as we bring the dumbbell down to extend our elbow. Now when we're doing a push-up, we're eccentrically contracting as we go down towards the ground because we're now elongating this tricep muscle. That also means that it's the agonist muscle, it's the prime mover. It cannot be our pronator teres or pectoralis major. So our pectoralis major, you know where that is. It's right here on your chest. We're only talking about flexion and extension, and we're talking about it at the tricep and the bicep. So that's really important to note as well. That is why the triceps brachii is the answer. Question 3. The action at the elbow and wrist joints is taking place in the sagittal plane. So this is really straightforward. We've been over planes of motion for about 4 weeks now. The plane of motion that's the action that's happening in the sagittal plane is flexion and extension. So that's how you concur that the wrists and the elbows are both in the sagittal plane, because we talked about flexion of the elbow in question 2 and extension of the wrist in question 1. We didn't talk about abduction, adduction, internal rotation, or external rotation. So we can automatically cut out coronal, frontal, and transverse. And our answer is sagittal. Question 4, the athlete's forearms are in a pronated position. So this is pretty simple as well. If you know pronation and supination, you should be able to determine this answer fairly quickly. Pronation here means that the palms are facing the ground, which they are as the athlete is doing a push-up. Supination would mean that the palms and forearms are facing the sky. So it's very clear that her forearms are facing the floor, so she has to be in pronation. She's not internally rotated or externally rotated because that means that we would be internally or externally rotating our wrists and our hands in as well as our shoulders. And it's asking you what position specifically the forearm is in. And internal and external rotation is dictated by the shoulder. So because we're in extension and flexion, it's very easy to concur that because our forearm and our wrists are pointed, our palms are pointed towards the floor, we're in pronation. Question 5 through 7 is this video right here. I already wound it up for y'all. So she starts at the top of a bicep curl. She's in a concentric contraction right now. This means that her muscle is shortened during this contraction. So the action is occurring at the elbow joint. The action occurring at the elbow joint is extension. So I want you to watch her elbow right now. She brings the bar down and fully extends her arms, okay? So if you look at her bicep is now elongated as opposed to up here, it's shortened in a concentric contraction. So let's play it one more time. She extends her elbows down, meaning she straightens them, and her bicep is now fully in eccentric contraction, which means she's elongated her bicep. It can't be abduction or adduction because that would require free weights. Abduction would mean that she's pulling the weights away from her body, and adduction means that she would be pulling the weights in towards her body, closer to the midline. So she's really even with where her grip is, and she's just exhibiting flexion and extension. She exhibits flexion at the very beginning of the video. She's holding the bar up top, but the action occurring at the elbow joint in the video is extension as she elongates her arms and fully extends her elbow. Question 6, the primary agonist, which is basically the strongest muscle that's doing the action or the movement of the body, is the biceps brachii. So if we go back up to this video, you could see fully that this muscle is the prime mover, it is the agonist. The antagonist would be the triceps brachii. The anconeus is an extension of the triceps brachii. It's a small muscle near the triceps brachii, so you know that's not going to be the prime mover. And the lats, while they are engaged, we're not doing a lat pull down, so we're not just using our lats to pull a bar down. We're doing a barbell curl, which means that our prime agonist would be the biceps brachii. Question 7, the agonist in this movement is being contracted concentrically, eccentrically, and isometrically. So we've gone over these types of contractions. Just to refresh your memory, concentric means that the muscle is shortened, eccentric means that the muscle is elongated, and isometric means that the muscle is stationary. And a good example of this, besides our bicep curl, while it is an eccentric contraction, it's eccentrically contracting because the elbow is being extended, so the muscle is elongating. If it was concentric, it would mean that you would be pulling the bar all the way up. That's what it looked like at the very beginning, and it's not isometric because it's not stationary. A good example of isometric would be a plank. So if you're holding a plank here on your forearms, you're stable. You're not moving. You're not moving it up and down, flexing, extending. You're not abducting, adducting, internally or externally rotating. You are just still. And an isometric contraction is something that solely focuses on stabilization. So you want to make sure that you really know that concentric contractions produce force. Okay, so we're producing force as we are pulling a bar up in a bicep curl. Eccentric contractions reduce force, so now we're reducing force as the barbell is coming down in eccentric contraction and we're extending our elbows. And isometric creates stability. So an isometric contraction in correlation with that video would mean that we're just holding the bar at 90 degrees or anywhere really and just holding it there. We're just stabilizing the bar. So that's a good example of isometric contraction, is not just with the barbell but also with a plank. You're going for overall strength and stability throughout all of your muscles. You're not just using a prime mover. You're not just using, your biceps or your triceps. You're using all of the little muscles in between to stabilize your body, and that's what an isometric contraction is. Moving on to question 8. Which of the following muscles are not agonists at the wrist joint in the action above? So what I would encourage you to do is you need to look up these 4 muscles if you haven't. If you don't have them memorized and you don't know where they are anatomically near your wrist, then you need to look them up and memorize them. So flexor carpi ulnaris, flexor digitorum, and palmaris longus are going to be here closer to the wrist joint, which is what it's asking us about. Which of the following muscles are not agonists at the wrist joint? So we can concur that the muscles that are closest to the wrist joint are going to be the prime movers. So all 3 of these muscles are closest to the wrist joint, so they are the prime movers. Extensor carpi radialis longus is not close to the wrist joint. It's up here a little bit further up where the forearm is, and so we can concur that this is not the agonist at the wrist joint. Okay, so let's look at this video really quick. She's coming down. A lot of the force is happening right here with these agonist muscles, these 3 muscles. We're going to rewind it, and as she comes down and then goes back up, we are contracting our extensor carpi radialis longus, but it's not the prime mover. Okay, so it's not the strongest muscle within the movement. Question 9. As the athlete lowers into the bottom of the push-up, the wrist is undergoing concentric extension, true or false? So this question is false. The wrist is undergoing eccentric extension. So if we go back up here, remember that eccentric means that the muscles are being elongated and concentric means that the muscles are bunching up. So as she comes down, her muscles are being elongated. Her elbows come out, her muscles are being elongated eccentrically. As she comes back up, her muscles can then not necessarily relax, but they're in a concentric contraction because they're shorter than they were when they were coming down and they were stretched out. So that is why the answer is false here. She is an eccentric extension, not concentric extension. Question 10. Just before the athlete completes her first repetition, her right hand shifts positions. So if you look at her right hand in the video, her right hand or fingers point medially, meaning they rotate in towards the middle of her body. This action is a result of glenohumeral internal rotation. So the most important thing to remember here is that internal rotation comes from the shoulder. It doesn't come necessarily from the elbow or from the wrist. While you can internally rotate here, right, or internally rotate with your elbow, I can't even get it in the film. There you go. You can internally rotate in with the elbow. The prime mover here is your shoulder. So you want to remember that the more mobile joint dictates the motion of the body. So the more mobile joint, if we're talking about our arm as an appendage, is not the wrist, it's not the elbow, it's our glenohumeral joint. And I can see why we could get a little confused here, and this is why. Ulnar deviation means, if you know where your ulna and your radius is, you should know. If you don't, you need to go look at a picture of it. Means that our pinkies are coming out. Okay, so I'm rotating away from my body. It can't be ulnar deviation because our fingers said it, that our fingers are pointing medially in towards the middle of our body. So then we can cross ulnar deviation out. We can move on to radial deviation. Now, radial deviation does mean that our thumbs are coming in and our wrists are rotating towards the middle of our body. But it didn't ask us which part is rotating inwards. It asked us this action is a result of what. So it's asking us overall which primary action is a result of this movement. And we can conclude that it's not forearm pronation because while our forearms are pronated, our forearms are facing down, they aren't the actual result or the prime mover in this push-up. So our only two options now are glenohumeral internal rotation and radial deviation. If you know and you have memorized that the more mobile joint dictates the movement, dictates the motion, then you will understand why glenohumeral internal rotation is the answer. You have to memorize that the more mobile joint is the dictator of the motion. If you don't, then it would be really easy to put radial deviation because while she is radially deviating, the more important thing to note here is that it is a result of the glenohumeral internal rotation that's happening at the shoulder. So she couldn't radially deviate if there was no glenohumeral internal rotation happening at the shoulder in this push-up. So that is the reason why number 10 is glenohumeral internal rotation. A couple other things to note. You want to remember that flexion and extension are happening in the sagittal plane. You want to remember that abduction and adduction happen in the transverse plane. And you want to remember that horizontal abduction and adduction, meaning internal and external rotation, are happening in the frontal plane. Make sure that you're memorizing these concepts. Also, make sure that you're memorizing what eccentric, concentric, and isometric contractions are. That way you notice and you understand the difference on your midterm. That will really help you when you are answering questions on your midterm and even in future CAPs. So I hope that this was helpful for you. If you need additional help, please reach out to me. I would be happy to answer any questions that you have and just talk it out. Sometimes it helps to talk it out with your professor. So that is why I'm here. I'm here to help you. So if you need help, send me an email. Other than that, I hope you guys have a great rest of your week and good luck on your midterm. You guys will do great. I will talk to you all later and I look forward to reading your work. Have a great rest of your week.